on to our main problem here. Find the equation of the line passing through the point 6, negative 7, and perpendicular to this line, 5x minus 9y equals to negative 17. I'm going to draw, first of all, draw a little sketch of what's going on. And it's not mandatory to draw a sketch of this problem in order to work it, but it's a pretty good idea because it's not mandatory and it's work. I suppose some of you will not do this, but if you want to do well, then you learn these habits, and in so doing, you'll have not only a better idea of what you're trying to get, you'll also be able to find some errors that you might make along the way. All right, so that's my purpose of sketching. So first of all, let me see. We have a point 6, negative 7. 2, 3, 4, 5, 6. 4, 5, 6, 7. So it's down about here, okay? And I'm not going to worry too much about quality on this graph because it's just a sketch. It's not part of my final answer that I'm supposed to be presenting. What about this line? What's it look like? Well, I'm going to use the intercept method of graphing because x and y are on the same side. If x was 0, what would y be? Well, you would solve for y by dividing by negative 9. Negative 17 over negative 9 is positive 17/19. That's pretty close to 2. That's almost 2. So x equals 0. Y, a number, puts it on the y-axis. If y was equal to 0, then I'd be looking at something on the x-axis. Solve for x, divide by 5. X is negative 17/5. Negative 17/5, let's see, that's about negative 3 2/5. So it's, roughly speaking, about here. So this line, it goes about like that. It's a fairly gentle slope, probably a slope under 1. The line I'm looking for crosses through 6, negative 7. It runs perpendicular, so let me see if I can get on top of this and estimate a perpendicular line. Oh, about like that, maybe. Okay. This will be a little better on graph paper with a straight edge, but we're just getting an idea. So let's see, the slope will be negative. It's probably steeper than negative 1, so it's probably a larger negative number than negative 1. And the y-intercept is up here in the positive range, maybe around 2, 3, 4, 5. I don't know. I'm not sure quite exactly where it is, but it's probably above 4 or 5 and maybe as high as 10. Again, I'm just kind of eyeballing it here, not sketching very, very carefully. But the y-intercept is somewhere up in this range. And so we know that if my answer ends up with a negative y-intercept, it's wrong. If I end up with a rather small positive y-intercept over here, it's got to be wrong. And if I get a positive slope, it's got to be wrong. So that's ways you can find yourself catching errors. Okay, so I'm going to erase it now, only because I need the board space. But you know, if you do this, don't erase it for me. Leave it on there. Let me see how you're working the problem. So recall our sketch here. When we look at the answer later, we'll kind of compare. All right, well, to build the equation of the line, I need 2 pieces of information. What are they? That's one piece of information. We have a location point, 6, negative 7. Other information I need. Well, the only other thing they tell us is that this line we're building is perpendicular to this line. So this gives us slope information. If I know the slope of this line, then I can use the perpendicular relationship and calculate the slope of the line I need. Well, to find the slope of this line, I think probably the easiest thing to do is to solve for y. So if we rearrange this in the slope-intercept form, which is also the function form, linear function form, then we're solving for y. I'm going to subtract 5x from both sides. It gives us minus 9y equals negative 5x minus 17. And we have to solve for y, which means I need to divide by negative 9 each term. And so this gives us y by itself is, and here are these two negatives cancel, those two negatives cancel. So I have positive 5/9 x plus 17 ninths. All right, well, I'm not really interested in the y-intercept. I want slope information from the known line in order to get slope information for the line I'm solving. So that's the number of interest. The known line has a slope of 5/9, then what is the perpendicular slope? So we're going to use a slope which is the opposite sign and inverted. So I get negative 9/5 is the slope I should be using. So these two slopes are perpendicular. All right, and I'm going to erase this. Normally I would say don't erase your work, but I'm going to make room. So now this did fit the picture I had up here earlier, because this slope is close to -2, so it's a little steeper than 45 degrees. It's a little steeper. And so far so good. Seems like we're on the right track.